Let's summarize the integration by parts rule. We have a question, we have to find the derivative of integral of hx with respect to x. We will write hx as the product of two functions in which one is f of x, the second is g dash x, where the antiderivatives gx of g dash x is known. We will be aware of the gx. So the selection is made as the product of fx g dash x. Take the derivative f dash x of f of x. F of x is indicated as a part, as a factor of the integrand. We will take its derivative. No, now we will move to our formula 1, which is mentioned here. We have selected fx and g dash x. Its antiderivative is known. We can easily write fx gx, and with negative sign we have an integral which have integrand f dash x gx. So we will evaluate in this way, or we will write it in simplified form, the formula 1 as u dv, which is equal to uv minus v du. Integral of u dv is equal to uv minus integral of v du. We note that when we want to integrate by using the method of integration by parts any function hx, which is the product of fx g dash x, or u du by dx. The factor g dash x is a function whose antiderivative is v or g of x, can be found. With a good choice of u and v, the integral becomes simpler than the original problem u dv, integral of u dv. If we will select the properly a good selection of u and v, we will easily solve the question. And you can improve this ability by practice. And the last reminder, do not forget the minus sign. Let's see an example. This example consists on two parts. You will try to solve it. Let's see its solution. We are well aware of formula 1, which is the formula for integration by parts. We have to select two functions fx and g dash x. Here two functions are given. We have to nominate one as f of x, the second as second as g dash of x. We say fx is equal to x, while g dash x is sine of x. We can obtain gx from this, which is minus cos of x. This gx will be used while evaluating, and the f prime x f dash x is equal to 1. This will be also be useful for the evaluation of the party. Here x is f of x sin x as g dash of x. We will write fx gx. Gx is minus cos x and fx is equal to x. This minus sign is with cos of x. Here is the product of fx gx, the negative sign here. And integrand is 1, the product of 1 with gx, which is minus cos of x. This is actually the integral of f prime x and g of x. Both are available. We have calculated f prime x while g dash x is also evaluated. So we will write down here in this integral sign. It's easy to evaluate the integral of minus cos x, which is minus sine of x. Simplifying, we obtain the final result as minus x cos x plus sine x plus c. Let's see the second part. Let u is equal to x squared. By second formula, short formula is used here. U is equal to x squared and dv is taken as sin x dx. U dv. To apply formula 2 for integration by parts, we need to know about v. While we have dv, so we will be calculated as just taking the integral of v, we obtain minus cos x. Now x squared sin x is equal to uv minus v du, which is equal to minus x squared cos x minus integral is integral of minus cos x 2x, and simplifying we obtain this relation. Now using the result of example 1, which we have solved in the first part, we can write this solution, which is evaluated by integrating by parts, and finally this is the answer of the part B. And if you want to check the result, you can differentiate, and it's easy that many terms will be cancelled out and you will be left with the integrand only. Another example which is related to the log of x and exponential function. In first part, we have to integrate log x with respect to x, and in the second part, we have to integrate this product. Here we see that only one term, which is log of x, while in B part there are two terms, but we have to use the method of integration by parts for evaluating A and B. Then what is the second part? Let's see the solution. If we write 1 as a product here, then this log x is equal to u, where dv is equal to 1. Then du is equal to dx by x, or it can be evaluated easily as uh, integral of 1 is x. Now using the formula, we will use u here, while v, which is the integral of 1 minus this x, and derivative of f of x, which is 1 over x, which is x log of x minus 1 dx, which is equal to minus x. So the final solution for the part A is x log x minus x plus c. Let's see the second part. We select x as u here and v as e power x, because we know that derivative of v is equal to e power x. So using the formula, we will write here first function and second the derivative u, and this whole is dv, which is equal to u dv, which is equal to uv minus v du according to the formula. Now replacing the values of u and v, we take, so this is the u and this e power x is v, negative sign, integral sign, and here it's v, while du is just dx. This integral can be easily solved. Finally, we will take this solution. These two parts involve log x and exponential of x. Now we will consider some example which will contain both e raised power x and trigonometric function sin x. Applying integration by parts twice, we will implement this method 2 times to find out the solution of e power x sin x. Let's select u as sin x, while dv, which is e power x dx, and definitely v will be e power x, which will be used later on. Now using the formula u dv, sorry, u is sin x, u, and dv, which is equal to uv minus e raised power x, which is v, and cos x, which is the integral of sin x, which is the derivative of the sin x, du, which is the derivative of Simplifying, we obtain this, but we want to find the solution of e power x sine of x. Here this part again involve e power x and cos x, a trigonometric function and an exponential function. We apply the integration by parts rule and we obtain this thing. We will replace this value instead of this. Next we will see that the right hand side will contain e power x sine of x with negative sign, integral of e power x sine of x with negative sign, while left hand side is already the same. Now we will shift this term to the left side and we will find the solution easily. The unknown integral which we have to evaluate is this. This appears twice in the equation on the left hand side and also on the right hand side. Writing I for this integral, let's say that it's equal to I, and which is appearing here on the right hand side while on the left hand side also. Solving for I, we obtain this. Simply we shift this I on the left hand side and we obtain this solution. And we can write the solution of the given integral f. And hope you will remember the I method. Let's see some other examples. This is an example which involves algebraic expressions as two factors, while first factor is x power 7 while the second factor is x power 4 plus 1 whole power 2 by 3. We have to evaluate the integral of this product. Let's see the solution. Taking x3 out of x7 and grouping it with this, we get the expression which we can integrate. Specifically, we set this as dv. So we select dv u is equal to this thing. U is equal to this while dv is equal to this. The product is the actual integrand. Just we have combined x cube with the second factor, while the first factor is remained as x power 4 multiplying and dividing with 4. This dv will help us later on. We have selected this as u. Now observe the next step. If this is u, then du is equal to just x cube dx. Now come to the formula. This is the actual integrand which is written as the product of u dv, where u is x power 4 by 4 and dv is mentioned here. This is uv. product of UV. We can calculate V from dV just by integrating this term. We obtain V. Now we have U, which is x power 4 by 4, and V as 3 by 5 into x power 4 plus 1 whole power 5 by 3, which the product is here according to the formula, then negative sign, and the integrand is again the product of V du. Sorry, the product of yes, it's dV, dV and du. Yeah, it's the product of V du because 3 by 5 is outside the integral. Now we substitute x power 4 plus 1 as W and evaluate this term, this integral, which results as mentioned here. The final result is the combination of above two results, which can be seen here. Simple manipulation will yield you at this stage.